Okay, so function application. So yesterday we learned rate of change and how to find the initial value. Okay, and we put them together and we formed what? With those two things. A function, right? Okay, so today we're going to do more of that, but using real world problems. Okay, so number one, a phone service charges $50 for a phone and $60 a month for usage plan A. Okay, so given that information, what is our one-time fee? What are we paying one time?
$50.
Okay, $50. Okay, so this $50, that's going to be what? Our rate of change or our initial value? Initial value, okay. So our initial value. All right, $60 a month. What do we call that? Our rate of change, okay. So that's what's changing, okay. All right, A, write a model function representing the total cost, C of M for usage plan A, for M months using their phone. Okay, so C of M equals something times M plus another number. Okay, what goes next to my variable?
16.
My rate of change or my initial value? My rate of change. And my rate of change we said was? 60. Okay, so that leaves
Our 50.
our 50, our initial value, okay? So C of M equals 60M plus 50. Okay, using your model, determine the total cost for 6 months of service. Okay, so we're given another number, 6. Okay, what am I going to do with that? I want to know how much money I'm going to pay for 6 months of service. So I can add, right, forever and ever and ever, or I can do what with this number? Okay, plug it in, right? I'm plugging it in to my function that I just wrote. Okay, so C of 6. So after 6 months, how much money have I spent for a phone and the service? $410. Okay. So $410 is how much I have spent for 6 months of service plus my $50 phone. Okay. So now, graph your model function. Okay, I'm going to make an XY table. Okay, at 0 months, okay, I pay how much? How much did I pay for my phone?
50.
I paid $50, right? So at 0, I start off by paying 50. Okay. After 1 month of service, how much did I pay? 110. Okay. Now, I'm not going to do 2, 3, 4, 5. But at 6 months, how much did I pay? We said 410, right? So now I have these points that I can plot on this graph. Okay, so at 0, I paid 50. At 1, I paid 110. And at 6, I paid 410. Okay? Now you're going to draw a line connecting those dots. I'm going to try. Ooh, so close. Okay. And I'm done with number 1. Okay, so I found my initial value, I found my rate of change, and I formed a function. Okay? All right, number 2. In 2008, the population of a town was 70,000 people. The population has been growing by 25,000 people each year. So, which of the two numbers provided is my initial value? 70,000, okay? So we're starting with 70,000 people. Okay, and what's the change that's happening every year? What's changing?
2,500.
Okay, 2,500 people, 2,500. So that's my rate of change. Okay. Now, complete the table below to show the population growth. So in 2008, I had 70,000 people. Okay, 2009, how many people did I have?
72,500.
72,500. 2010, 75,000. Okay, 77,500. And then 80,000. Okay, so write a model function representing the population P of t for t years after 2008. Okay, so P of t equals, okay, something times t plus something. Okay, so over here, what goes next to the variable? Which number goes next to the variable? 2,500, okay? Is it increasing by 2,500 or decreasing? Okay, so positive, right? Positive 2,500. Okay, and what am I starting out with over here? How many people?
70,000.
70,000, okay? So my initial value goes there. Okay, assuming that the population will continue to increase at the same rate, predict the population in the year 2018. So how many years difference is there from 2008 to 2018?
10 years.
10, okay. So what they're asking is estimate, okay, how many people there will be 10 years from now. Okay, so we're plugging in 10. So P of 10 equals 2,500 times 10 plus 70,000. Okay, 25 times 1 is what? 25, okay, and then I add the 3 zeros plus 70,000, and I get what? 95,000. Okay, so in 2018, 95,000 people. So this is like where I went to school in Utah. I don't even, yeah, that's still a lot less than Fullerton. Really small town. All right, what is the average rate of change associated with this problem?
2,500.
Increasing, right? So plus 2,500 people a year. All right? Any questions? Okay. All right, Jason and his dog travel 2 miles from their home to visit a friend. After arriving, the dog begins walking further away from its home at 3 miles per hour. Write a model function, d of t, for the dog's distance from his home t hours from now. Okay, so when we're starting, how many miles is the dog already away from his home? 2. In other words, 2 is my what? Initial value, yeah. Okay, after arriving, the dog begins walking further away from its home at 3 miles per hour. So what do we call that? Rate of change. So my 3 miles per hour, that's my rate of change. Okay, so go ahead and write a function for this one. Okay, so do part A. What did you guys get?
D plus 3D plus 2.
Okay, d of t equals 3t plus 2, or, okay, I kind of did it backwards. D of t equals 2 plus 3t, okay? So either answer, either one of these are fine. Okay, so graph your model function and label the graph. So down here on the x-axis, it's always time, okay? So we're measuring our time in hours. Then over here is our distance. And that's going to be in miles. Okay, so let's make an XY table to get some points. At 0, we're starting off with, he's how many miles away? 2. Okay. After 1 hour, how far is the dog away? 5. After 2 hours? How many? 8. 8 miles. Okay. So go ahead and plot those points. Okay, so 0, 2, 1, 5, 2, 8. Okay, now you're going to connect those. Okay, any questions on that one? All right, so let's move on. Okay, a dirt biker is 35 miles from his organization's clubhouse. The biker is traveling at 15 miles per hour toward the clubhouse. Okay. So he's 35 miles from his clubhouse and he's going back. So write a model function, b of t, for the distance of the biker from the clubhouse, t hours from now. So what is our rate of change? Yes?
15 miles.
15 miles. Okay, that's our rate of change. What is our initial value? 35. Okay. So we have 15t plus 35. Did anyone get anything different? Yeah. Okay. So what should I change here then? Yes, 15 should be negative. Okay. So b of t equals negative 15t plus 35. So if I am 6 miles away, or 6 feet away from Jackie right now, okay, just like the biker's 35 miles away from the clubhouse. If I am moving towards Jackie at 1 foot a second, is the distance between me and Jackie growing? Is it increasing or decreasing?
Decreasing.
It's decreasing, okay? So that's why that 15 is negative, okay? Because he's not biking away, he's biking to the clubhouse. Okay, so part B, how far was the biker from the clubhouse after 1 hour of travel? After 1 hour, okay. So in other words, what is B of 1? What is B of 1? Okay, so what did you guys get? 20. 20 miles, right? So the biker is 20 miles away after 1 hour. Okay, now graph a function, graph your function. Okay, so make an XY table. So at 0, he's 35 miles. At 1, he's 20. Okay, so we can just graph those 2 points. Should be hours. 0, 35. I'm way off. Okay, now part D. How long did it take the biker to return to the clubhouse?
2 hours and 20 minutes.
2 hours and 20 minutes. Okay, so back to my example with Jackie. Let's say I'm standing where Jackie is, okay? How many miles am I away from Jackie?
0.
I'm 0 miles away from Jackie, okay? So my total distance is now 0. So 0 equals negative 15t plus 35. Okay, and I have to solve for t. How long did it take me to get to 0 miles away? So that's 2.3 or 2 hours and 20 minutes. Okay, now, number 5.